The oil industry is recognizing the potential business impact of doing more with subsurface data using advances in scientific computing, including artificial intelligence and machine learning techniques. Modern drilling and coring programs generate a significant amount of digital data that traditionally exists in silos that separate it and make it very difficult to visualize and analyze in one place. All of this data exists in a wide variety of data formats and have unique characteristics about how they need to be processed and read. And Virtual Core integrates all of this data in one spot so it can be visualized and analyzed. Data cleaning and preparation is an important step, especially when dealing with geoscience data, which comes in from different vendors with different file formats and different amounts of data quality. DLIS files from wellbore images need to be parsed and put into a form that can be easily visualized. Well log have bad data region that needs to be cleaned. Core photographs often come in boxes that need to be extracted before they can be viewed in depth. And finally, CT data, it comes in a DICOM format that requires a significant amount of processing before it can be viewed and analyzed efficiently. Once the data has been imported and cleaned, automated processing pipelines can be run to extract features that can be used by the geologist for core description. Bedding curves, lamination frequency, dip angle, fractures, all of these can be automatically detected, significantly reducing the time it takes for the geologist to do core description. All of this data, when it's collected, is associated with its own depth scale, which often aren't aligned with one another. Well logs, core data, thin section images are all tagged to depths, and this needs to be aligned in order to visualize it in one place effectively. It also needs to be aligned rotationally, and Virtual Core includes tools to do all of this. In addition to 1D well log curves and 2D core photographs and images, Virtual Core also has a 3D visualization system capable of rendering volumes from core CT scans. This gives you insight into the interior structure of core, such as bioturbation and sedimentary structures that you couldn't see before. Once the data has been cleaned and aligned, it makes a great feature set for machine learning to be used to help rapidly describe the core, removing a lot of the tedious work that needs to be done. Clustering approaches can automatically determine significant units, suggesting to the geoscientists where similar rock types might be. Supervised approaches can learn from a geologist's description and automatically classify lithofacies and bioturbation indices, for example, throughout the entire core. Virtual Core simplifies the process of using this integrated data set and designing and building next-generation workflows. You can easily connect to this with Python and the scientific tools that are in that ecosystem. Virtual Core application brings scientific computing to core and well log data. It gives geoscientists tools to visualize and analyze integrated multi-scale geoscience data set, create new analysis workflows, and use cutting-edge machine learning technology to significantly reduce the time it takes to do core description.